Let's go over exam number 3. I'm going to start with problem 12 because it is most interesting problem. Again, I ask you to use acceleration due to gravity -10, and that's what I'm going to do. So I don't have to use the calculator. One thing I know, when you throw down an object, right, from 82 meter tall building, how long does it take? Well, there is an expectation, right? Expectation is about, I don't know, 4 seconds. How do you know? Because if the building is 80 meter tall, right, and you just drop it, it takes 4 seconds, meaning that initial velocity is 0, it takes 4 seconds. So then 82 is little higher than 80, right? Okay, and you throw down with only a little bit more than 0 initial velocity, that is negative 0.4 meter per second. It's not going to make any differences. Let's see whether it does make any difference. So d is equal to, but this type of intuition is important. This type of intuition is important, that hey, it's probably going to take 4 seconds, not 5, not 3, 4. Why is that? Because even I drop it from where, 80 meter tall building, 80 and 82 pretty much same, is going to take 4 seconds. All right, let's see. D is equal to, okay, so D is equal to VIT plus half AT squared. The building is 82 meter tall. Initial velocity is you throw it down, so negative 0.4 T minus half 10 T squared. So this is 5. So negative 82 is equal to negative 0.4 T minus 5 T squared. You're going to bring everything to the left side. 5t squared. You always want to make sure that the highest degree coefficient is positive. Yeah. Positive 0.4t minus 82 is equal to 0. Quadratic formula. All right, so minus b, what do you get? Minus 0.4 plus minus 0.4 square, 0.16 minus 4 times 5 times negative 82 over 10. So minus 0.4 plus minus, this is minus minus plus 4 times 20, 20 times 82, 1640, 1640 plus 0.16, so 1640.16 divided by 10. Okay, so negative 0.4 plus minus square root of 1640 is 40.4 over 10. We only going to take the positive. So negative 0.4 plus 40.4 is 40. 40 divided by 10 is 4. Okay, so the tree was 4 meter long, 4 second long. So 4, 4, 4, 4, 4, 4. Okay, so pretty easy. That's how easy it is. Okay. All right, now let's see. The you're gonna this is the rooftop, and rooftop you're gonna use it as a 0 comma 0, right? So that would be easy. So this is, the distance is 0 here, or displacement is 0 over here, right? And and the time is 0 over here. So this is 1, this is 2, this is 3, and this is 4, so on. Okay, good. And that's what we're gonna do. And we're gonna write negative 82 over here. Okay, that's pretty much it. And we're going to take the absolute value of this one, okay, without even thinking much, because distance is absolute value of displacement. Okay, and don't forget to put 82. At 4 seconds the height is 82. At 4 seconds the height is negative 82. Okay, I'm gonna do the velocity now. To take the velocity, this is second degree polynomial, this must be first degree polynomial, this is curve, this must be a horizontal line. So however, you just cannot start from here because there is an initial velocity that is negative 0.4, right? And you go down until 4 seconds, right? So you have a final velocity. How much is the final velocity? Bf is equal to bi plus at. Vi is negative zero point 0.4 minus 10, t is equal to 4. So you are talking about negative 40 or the negative 40.4. This is what you are talking about right here. Okay, good. So now you have a rectangle and you have a triangle. Okay, all right, that's pretty much it. That's all I ask you to do. Make the 4 visible. All right, so take the absolute value of this one. So zero point 0.4, absolute value of negative zero point 0.4 is zero point 0.4. Absolute value of 40.4 is negative 40 is 40.4. That's pretty much it. Okay, that's it. Okay. All right, so acceleration due to gravity, negative 10, positive 10. Okay, that's the problem number 12. Pretty easy, right? Okay, now we're gonna go to problem number 1. What is happening with problem number 1? There is a slope, right? There is a road. There is a road with this is the road, right? A kind of slopy, like steep. And this is how long? This is how long the road is, 5 meter long. All right, initial velocity of the car, initial velocity is 1 meter per second, and final velocity of the car is 4 meter per second. What we want to know, the time it takes, right? So vf square is equal to vi square plus 280. So 4 square is equal to 1 square plus 2 times acceleration, and d is 5. So 16 is equal to 1 plus 10a, right? So 15 is equal to 10a. So a is equal to 1.5. Now, of course, you can uh, solve this one by vf is equal to vi plus at. So you are trying to find the t. Vf is 4, Vi is 1 plus 1.5 t. So 3 is equal to 1.5 t. So t is equal to 2 seconds. And that is, so what's going on? A car is moving with, the car is moving with uh, initial velocity. So Vi is 25 meter per second. All right. So you hit the brake. So the velocity is going down because you hit the brake, right? And so the final velocity is 0 meter per second, of course. Um, how long it took from 25 meter per second to go to 0 meter per second? It says that 40 meters. All right, what do you want to find? Acceleration. This acceleration. Acceleration was constant. This is velocity. Velocity is 25 to 0. Acceleration remain constant. To the other direction, we're trying to find the acceleration. Vf square is equal to Vi square plus 280. All right, so Vf square is what? 0 square, because your final velocity is 0. Va square is 25 square plus 2 times a times d is 40, right? Okay, so you have acceleration is 25 square over 80, and that is 7.8. Acceleration is 7.8. That is number 3. Okay, number that is choice 3. All right, problem number 3 is pretty easy. A break is just from anything, is just from rest. All right, a free fall, right? If you drop it, this is free fall, right? Now dt st, how the dt st vt displacement versus time and velocity versus time look like? Well, displacement versus time should look like this. If you drop something with initial velocity 0, of course, because that's what it is from rest. Okay, and velocity versus time would look like this. Take the absolute value, this, and take the absolute value of this. Okay, and if you do the AT graph for this one, the AT graph would look like what? AT graph would look like absolute value of a is look like constant, right? So this is constant. Uh, so it says that as it falls, the acceleration is constant and is speed increasing. Is speed increasing and acceleration remain constant. Problem number 4, you throw up something to the air with how much velocity? 9.8. So you throw up something to the air, right? This is dt. You throw up something in the air with initial velocity 9.8 meter per second. All right. Uh, okay, so like at 90-degree, right? So you want to find the maximum height. What is the maximum height? One thing you know, at max height the velocity is 0. You're going to use that fact. This is max height. Vf squared is equal to vi squared plus 2ad. If you put 0 over here, it's going to give you the max height. So 9.8 squared plus 2 negative 10d. So d is equal to 9.8 squared 20. So the d is equal to um, okay. So this is like 10 squared. So this is 100. 100 divided by 20. This is 5. So you probably gonna choose 4.91. You don't need calculator. Okay, and that is problem 2. Problem 5, that is option choice 2. Problem 5, you do experiment to find out the acceleration. To do that, you drop something and you measure how high does it go and how long does it take. If it goes like if it falls 2.4 meter, it takes 0.71 second. Now you want to know acceleration due to gravity. Okay, it doesn't have to be, you are not necessarily be on the earth. Okay, so how can you do that? So d is equal to vat plus half at squared. But you know that when you drop something, it is 0. How much does it fall? 2.4. Half acceleration, you try to find it. T squared is 0.71 squared. Now acceleration is, then you can, this is 6.8 dt dt st acceleration versus time, displacement versus time, vt, and acceleration versus time. When something falling freely, the displacement versus time is this one, velocity versus time is this one, absolute value of this one is this one, and absolute value of this one is this one, absolute value of this one is this one. All right, so whose graph look like this one, distance versus time, this one. And whose graph best represent the relationship between acceleration and time of a free falling body? Of course, this one. Let's consider two scenarios. One scenario, you throw the ball with 10 meter per second. So the velocity has two components, vx and vy, right? Vx is 10 meter per second, and vy is always 0. And then this one, of course, you double it, right? 20 meter per second. Vx is 20 meter per second. And Vy is, again, when you throw something with, um, it's like, you run off the cliff. When you throw something with horizontal velocity, the vertical component of the velocity is 0. It's just like you fall, you run on the rooftop, and at the edge, you run off the rooftop. Okay, so if this one is D, this one has to be 2D. That's the answer. Why is that? Okay, because the height is same, right? Height is same, so it doesn't matter. So consider height is like, I don't know, 20 meter. Then this one is also 20 meter, right? And the D, you're gonna see that the D, if this D is like 5, this D would be 10. Okay, take a look. How can you find the time? By d is equal to vat plus half a t squared. Always at the y component give you the time. So y component give you the time. So this is 0 because this one is 0. So d is negative 20 is equal to minus 5 t squared, right? So 5 goes to 24 times. 4 is equal to t squared. T is equal to 2. All right, so the time it takes 2 seconds. So the time it takes 2 seconds. All right, so then the Vx is given 10. So dx is Vi x t plus half ax t squared. This is 0 because acceleration due to gravity and the x direction is 0. So dx is equal to 10 times 2, 20, and this one has to be 40. Dx is equal to Vix times t. So 20 times 2, 40. Okay. All right. So then if this is d, then this must be 2d. Okay, that's the answer. Okay, let's go over problem number 9. Problem number 9, I said it many times, is like problem number 8. The Vy, so velocity, initial velocity has a two component. Initial velocity has a two component, Vx and Vy. Vx is vertical velocity is 26. Vertical velocity is 26, and vertical velocity is 26, and horizontal velocity is 15. Okay, so what are you trying to find? The time. So if you want to find the time, Vf is equal to Vi plus At, and that's give you the time. Um, what else you know? That's pretty much it, you know, right? A projectile is launched from a level ground with an initial vertical, this, and upward is this. Calculate the total time the projectile in the air before. Okay. So the total time the projectile in the air. Okay. Um, hmm. So let's say this is displacement versus time graph, and let's say velocity final is 0 over here. So put the 0. So VI y, of course, and AY. VIY is how much? 26 minus 10t. So this gives you 2.6. The total time is not 2.6. 2.6 is because I put the velocity, uh, at max height, it takes 2.6 seconds for the ball to go to the max height. Why is that? Because the max height, the velocity final is 0. So it's 2.6. If this one take 2.6, this one take what? 2.6 times 2. Uh, okay, so that is 5.2. So the answer is 5.2. 5.2, and this is 2d. 5.2 seconds. You can do you can do a different way. You can do it Vf is equal to Vi plus At. All right. If the Vy is 26, initial Viy, then this is negative 26. Okay, and this is how you can also get negative 52 is equal to this is negative 10, and this is how you also can get 5.2. Okay, very good. Now number 10 is connected with number 9. So number 10, I ask you to find the range, right? The horizontal distance. So I ask you to find the range. So how you can find the range? So Vi, it has two components, Vx and Vy. Vy is 26 and Vx is 15. And I ask you to, how long does it take? Uh, so a projectile is launched, right? dt, a projectile is launched. So you are trying to find the dx, this one dx. So dx is Vix t. All right. So how long did it take? From here to here, it takes 2.6 seconds. From here to here, it takes another 2.6 seconds. So it's 5.2 seconds altogether. Right? Okay, good. So then dx is equal to Vix is 15. 15 times 5.2. 15 times 5.2 is 15 times 5 is 75. Is 75 or 70? So 15 times 5 is 75. So it should be more than 75. Okay, number 11. That takes us to number 11. Okay. So number 11. Um, okay, so a car, so number 11, a car is initially moving with initial velocity is 25 meter per second, right? West, so it must be negative. Okay, accelerating uniformly at the rate of acceleration is 1.5 meter per second squared. All right, to the east, so this must be positive. For 6 seconds, time is 6 seconds. Time doesn't matter, direction doesn't matter. Time is always positive. um, Calculate the total distance. So many way you can find this one, but the best way to find this one, distance is equal to VIT plus half AT squared. Now distance is VI is negative 25, time is 6 plus half, acceleration is given 1.5, so 3 over 2, and the time is also given 36, right? So now D is equal to negative so 150, 4 goes to 36, 9 times, plus 27. All right, so G is equal to negative 1.2 meters. So since it is a distance, you take the absolute value, so 123 meters. Again, if you wrote, some of you wrote negative 123 meter, you did not lose any point for that. Problem number 12, we already did it in the beginning of the tutorial.